All right, guys. Okay, we're going to talk about properties of exponents. Okay, this next chapter is going to begin discussing polynomials. Okay, and in order to do that, that involves powers. So we're going to work with some properties of these exponents. Okay, just really quickly, as far as what an exponent is. Okay, so exponent just represents repeated multiplication. So this means that a is being multiplied by itself m times. Okay, and as far as just terminology, if you hear me refer to the a, whatever number is being repeatedly multiplied will be referred to as a base. The number of times that it's being multiplied by itself will be referred to as a power. And the whole thing generally is called an exponent. Okay, so there's a couple properties that you should be aware of. Again, your calculators automatically take them into account, but oftentimes this leads to kind of either direct solutions on standardized testing, and many of you are going to be taking SATs here either this spring or next fall. And if you know these properties, it opens up some solutions to problems that are quicker than if you try with your calculator. Okay, so some of the properties of exponents that you need to be aware of. If you multiply two powers or two exponents with the same base, does anybody recall what you do with their powers? You add them. Okay? So when you multiply two numbers with the same base, you add their powers. Okay? So if you're looking at an example where you take 3 squared times 3 to the 5th, and you don't have to expand these out and find what the equivalents or the numbers are. You can just solve them as powers or as exponents. And when you would do this, you take your common base of 3, and then what's your new power going to be? 2 plus 5 or 7. And again, remember when you're entering these on the computer, it's 3 to the power of 7 would be represented as 3 to the 7th. Next power, or the next property to be aware of is if you take a power to a power. Okay. Anytime you're taking a power to a power, realize what the powers represent. It just means repeated multiplication. So this is really saying you're taking a to the m times a to the m times a to the m n number of times. And so here, because your bases are the same, you're multiplying, you would add these powers. Adding m to itself n times is equivalent to doing what? If you add 3 to itself 8 times, 3 plus 3 plus 3, 8 times, you could simplify that by saying what's 3 times 8, right? So this is the same idea. It's m times n. So when you take a power to a power, you simply write the common base or the original base and you multiply their powers. So here, if you were taking this similar example of 3 squared to the 5th power, that's equivalent to 3 to the what? 10, 2 times 5. Right, the next is if you have a product that's the base of a power, that power is going to apply to all factors of the product independently. So you can split this up as saying it's a to the m times b to the m. If there were other factors inside that product, the power of m would apply to those as well. And again, the most common spot that you might see this would be something of this nature. If you have the base of 3x to the power of 4, that 4 is going to apply to every individual factor inside here. So 3, that base of 3 to the power of 4, the base of x to the power of 4. If I had another base inside here, another factor, that would also be taken to the power of 4. Okay? So when you take the power of a product, the power applies to all factors of the product.